Hi, I'm Cheryl Leach. In this problem, we're going to find the area of the region bounded by the curves y equal the cosine of x, y equals 2 minus the cosine of x, and I'm also going to be bounded by x equals 0 and x equals 2 pi. Well, I already have my curves sketched up here, and so just to be clear, I'm looking for the region bounded by those two curves. Okay, well, I know how to find the area of that region using integration. So the area is going to equal the integral from a to b of the top function minus the bottom function, dx. So in this particular problem, my left limit is going to be 0, and my right 2 pi. So my limits of integration will go from 0 to 2 pi. The top function is the 2 minus cosine x curve. So I have 2 minus cosine of x. Then I need to subtract the bottom function, which is my cosine curve. Only one term, so I can just subtract cosine of x dx. All right, let's do a little simplifying before we dive into integration. So we have the integral from 0 to 2 pi of 2 minus 2 cosine x dx. I can use my basic rules of integration to do this one. The integral of 2 dx, that's just going to be 2x. And for 2 cosine x, that minus 2 is a constant multiple that can be pulled out. And the integral of cosine x is sine x. And then I need to evaluate this from 0 to 2 pi. So using my fundamental theorem, I'll plug in the upper limit. So I have 2 times 2 pi minus 2 times the sine of 2 pi. And then I'm going to subtract what happens when I plug in my lower limit. So I'll have 2 times 0, which is just 0, minus 2 times the sine of 0. So I have 4 pi minus 2 times the sine of 2 pi minus 0 plus 2 times the sine of 0. Now, 0 and 2 pi are both special angles, so you should be able to evaluate the sine of those angles. So we're going to have 4 pi minus 2. The sine of 2 pi is 0. Then we're going to add 2 times the sine of 0, and the sine of 0 is again 0. And so I end up with 4 pi. Now again, we have an area, so let's write this as 4 pi square units. And that's the area of my region. I hope that was helpful. Thanks.